Fordham here. Today we're going to talk about solving quadratic equations. Now, some of you may actually think this means factoring, and it partially does actually. And there's kind of a two-step approach to what we're going to do today, which is the first part is factor, and we're going to take some quadratics and we're going to factor them. And the second part is we're actually going to go ahead and set them equal to x, or sorry, I should say 0. And what that's going to do is actually help determine something called roots, which we've talked about before. And we'll go into a little bit more detail about what exactly roots are. So, I have an example up here, and I have x squared plus 7x plus 10 equals y. Now, in an earlier unit, we learned even how to graph this, and I happen to have the table right next to me here, so I'm just going to go ahead and throw it up real quick. I know I have negative 6, 4, I have negative 5, 0, I've got negative 4, negative 2, and then I've got negative 3, negative 2, looks like negative 2 is 0, and 1 goes back up here. So I've got a graph that goes something like that. And remember, the lines go on forever. The roots that we're explicitly looking for are right here. And so roots is the same thing as saying x-intercept. Means the same exact thing. Now, sometimes it's very easy graphically to do this, but other times it might just be simpler to go ahead and solve it algebraically. So what we need to do is make sure that the equation we're working with here is equal to either y or 0. If it's already equal to y, we can actually just go ahead and set it equal to 0. And the purpose of that is by making y 0, if you look at the graph, the x, where the x-intercepts are, the y value is 0. It doesn't go up, it doesn't go down. So this is why we set it equal to 0. So here we go. I'm going to rewrite this equation. So x squared plus 7x plus 10 equals 0. And I'm going to go ahead and do the very first step as mentioned above, and I'm going to go ahead and factor this. So I'm looking for the factors of 10. It's pretty easy. There's only 2. It's 1 and 10, 2 and 5. And the number I'm looking for in the middle is 7. So we have 11 there, we have 9, we have 7, and we have 3. Oh, good. So when I go to set up my factor, it's going to be x with a 2, x with a 5. Since it's a multiplication for plus, they need to either be both positive, both minus. Since the number in the middle is positive, they're both positive. Now remember, this is still equal to 0, and it's okay that I flipped it around. It doesn't make a difference. Now, here's where it gets a little tricky, and we're going to go ahead and involve the second part of set it equal to 0. What I'm going to do is take the two binomials and split them apart. And what this is going to do, it's going to find the two roots, or the two x-intercepts of the quadratic. So here we go. On the left side, I'm going to rewrite this as x plus 2 equals 0. And what I'm going to do is solve for x. So I'm going to subtract 2 from both sides. Those cancel out, and I find that x equals negative 2, which is one of our roots. If I go back to the graph and look, I can actually see negative 2 right there is the x-intercept. Well, let's go ahead and do it for the other side. So now we have x plus 5 equals 0. Same thing, I'm going to solve for x. So subtract 5, and we're going to get x equals negative 5, which again, that's the other root. So that's your answer. So to solve a quadratic equation, what you need to do is make sure it's set equal to 0, or if it's just set to y, that works too. And then you're going to factor, and then set each binomial equal to 0 and solve. Now, some of you might start picking up on it. If you notice, on the inside, it kind of just, the sign almost flips. And there's a shortcut to that, but let's not focus too much on shortcuts yet. Here we have another example. We have f of x equals x squared plus 3x plus 2. Now, do not be fooled by f of x. This is the same thing as saying y equals. There's no difference at all. So if this confuses you, scratch it out and just call it y. It means the absolute same thing. Don't fall for that little trick. I'm going to go ahead and plot again. I have the table already pre-generated, so that way it would save us just a little bit of time. Looks like negative 3 goes to 2, and negative 2 goes to 0, and negative 1 goes to 0, 0 at 2, and 1 at 6. So you can see our graph goes slightly below and like that. And again, it's a line, it's a curve, so it goes on forever. And it's pretty easy graphically to see our two roots down there. They should be -2 and -1. But let's go ahead and check with factoring. So what I'm going to do, I'm going to take x squared plus 3x plus 2. It's already set equal to y, which is fine. So actually all we're going to do is just go ahead and change that to be equal to 0. And again, we want to find these x-intercepts. So we always change the y value, the opposite intercept, to 0. So I'm going to go ahead and factor. And, well, the factors of 2 could not be easier. The number in the middle I'm looking for is a 3. Oh, look, there it is. Boom. So I'm going to go ahead and use the factors of x with a 1, x with a 2, still equal to 0. Okay. Positive for multiplication, so they both are positive, both are negative. Sign in the middle is positive, so they're both positive. And again, now we've factored it, we need to do the second step, which is set both sides equal to 0 to find the roots. So I'm going to go ahead and break the binomials apart. We're going to do x plus 1 equals 0, and we'll do x plus 2 equals 0. Subtract 1, subtract 1. So the first root we find is x equals -1. Oh look, that was where it crossed the x-intercept. And we're going to subtract 2 for the other one. X equals -2. Oh man, that was the other root. So that's all you have to do to solve quadratics. Factor, set each binomial equal to 0, solve for x. Simple as pie. Thanks for watching.